So before we start, Zaid, so one thing that I have to tell that on today is Tuesday. Yes, correct. 6th of March, Tuesday.
Mhm.
Correct, Zaid?
Yep.
Yeah. So on 9th of March, 9th of March, that will be uh, Thursday, Wednesday, Thursday, Saturday. Correct? 9th of March, Saturday.
Yeah. Yeah.
Yeah. So there will be a test of yours based on Unit 1. Unit 1 that we had completed. In that unit, there are two chapters. So there will be a 80 marks test. I'll write it on the board and it will be more clear there.
Hmm.
Okay, Saturday is feasible or shall I take it on Sunday? What is feasible more? Saturday or Sunday? Which weekends?
Saturday is fine.
Saturday, okay. So chapter 1 and chapter 2. In unit 1, there are two chapters.
Hmm.
So what I'll do, I'll forward you the paper in the morning. Okay. So you have to set 80 marks paper. 80 marks paper. Okay. So generally you require 3 hours to solve it. You can require less also. You take 3 hours to solve and see in how much time you solve. Is it clear?
Hmm. Yep.
Okay. So what I'll do, I'll take this and share it on our WhatsApp. So now we'll start with our topic. That was we were on our regression
Hmm.
regression line, and we have seen that on regression line there were there were okay there were many errors, many errors and misinterpretation and misinterpretation. So we proceed to we proceed to least square regression. Least square regression. Okay. So least square regression. What is least square regression? We'll see on to it now. Okay. So least square regression is generally here we'll come on to that. We have seen how we used to predict the value using the regression, and we have seen in interpreting a regression line what is A and what is B. Yes or no? B was the slope and
Hmm.
A was the y-intercept. Now we come on to this was the example that we had seen here. We have
Hmm.
discussed this example. I think see here what he is explaining. that some of the residuals here, some of the residuals that I've told you, that this line is generally plotted by taking the means of all the points, and it is between, and this line, the regression line, is in between all the points. So this is the sum of the residual. Means what? We see likewise, for example, this is our y-axis, this is our x-axis, and this is our regression line. For example, these points are there. Okay, so when we'll take the distance, this is, I've told you in the previous class that this is known as residual. This is another residual. This, the upper residual, that's, for example, this height is 3. So we'll take it as +3 if it is upside. And for example, this height is 2. So we'll take at -2 as it is downside. Okay. So now I'll measure this height. For example, its height is -1. This height is, for example, 4. This height, for example, it's 2. This height, for example, it's 1. So when we'll, or there are also on the negative side also likewise -7 for suppose. And here for suppose -1. So when we'll add all this, likewise 3 plus 4 plus 2 plus 1, this is the positive 7, 8, 9. 7, 8, 9, 10. Correct? Just a minute. My phone is ringing. Just a minute. Okay, so I'm back. So this is +10. Okay, and the downside it is -2, -2, -1, -1, and -7. I think. What I'll do, I'll erase -1. This. I'll erase this and add one more -1. For example, this is -1. Okay, so it will be -1. So this is, so what it is, it will be, the sum will be -10. So what does it do? -10 and +10. When they'll add into it, -10 plus 10, the sum of the residuals, it is the sum of the residuals. What it will be, say, it will be exact 0. It will be exact 0 in each and every. It will be, it will be, it will be 0 in every regression line. In every regression line. So what does we do? So for this, we generally consider the square of sum of the squares, it will be correct. If I am here,
Mhm.
sum of the squares, yes, there is a difference between sum of the square and square of the sum. Do you know the difference?
Mhm.
See, I'll show you the
This
difference.
one is this one.
You know the difference between square of sum and sum of square. There is a difference. Sum of squares. The difference is that here square of sum means we have to square the sum, and here sum of the square means we have to sum the squared ones. This is the big difference, and they are not equal. You know that, right?
Yeah, I
Yeah,
know.
they are neither equal, because the expansion of this is, you have seen in mathematics, the expansion of this is x square plus 2xy plus y square. So this term is missing onto here. Therefore, they are not equal. Please remember. So we consider squared sum of squares residuals. What do we generally do? Residuals. We have seen that it was coming -10, so generally we square it, so it will be 100, and we square the positive also, then it's 100 also, and then we'll add. This is for the negative side, downside, and this is for the positive side. Now we add n plus n square plus p square. So it will be 100 plus 100. So it is 200. Yes or no, Zaid? So this,
Yeah.
see, sum of residuals was coming 0, and sum of square residual is coming to be 200. So this matters. Okay, remember this. Is it clear, Zaid?
Mm-hmm. Yeah.
Yeah, yeah. So this is the thing what he is generally doing in this graph generally. Okay, so I've told you the lesser a good regression line uh, will have a sum of residual near 0. A good regression line, which is a good
Mm-hmm.
regression line, it will have the sum of the residual near to 0. Okay, but the regression line we prefer is the one that minimize the sum of the squared residuals. I'll take this thing into constant that nearly for all, for I've told you, for all residual lines, the sum of residuals will be 0, near about 0, approximately 0. Okay, and it is a good regression line. It is a good regression line if it's, I write the short form SOR is equals to 0, but we look for a line, look for a line whose sum of sum of square residual is very less, so that our estimation doesn't go wrong. Okay, so I'll come on to this. This is the thing, that's why the line 3.9b shows. So this comes, that is least square regression. Here comes the topic, this what we that I have defined here the whole thing. What we are doing, Zaid, we are looking for
We're
very
trying to
less,
find something that's closer to zero.
yes, very less means least. And what we are doing in SSOR means sum of squared. So where does the name come? I'm telling you this, sum of squared residuals. So this square comes least square. This square comes from here, and this is regression. So what we will do in regression, that we will see that the SSOR is very small, not 0. The SOR is near about 0. But the SSOR is very small. That is very small means least that we can obtain, least that we can obtain. So SS are very small. So it will be least square regression. This is the thing. This is least square regression. And there are multiple software in which there is a one software that says Python, then there is an Excel visualization, then Power BI visualization. There are different software that generally does this things in quite a minute, or you can say in quite seconds. They plot the least square regression line in quite seconds. Okay, so this is the definition. The least square regression line, I've explained you the whole thing part by part. The least square regression line is the line that makes the sum of squared residual as small as possible. Did you get that, Zaid?
Yeah.
Yeah. So now we'll move on to an example so that the things will be clear. See, he is given here. This thing that we are going to do, that the plotting the least square regression, it is a tedious task on pen and paper. This task, this task is very tedious, means very difficult. Difficult means it's
Yeah.
tedious, very long form. To do it by pen on paper, to do it by pen and paper. So generally you will use softwares. Softwares will be used for this. Okay. Okay. So you can do it on pen and paper, but in your book it's not there. Okay. So this is the data that he has given to us. We had done the regression line for this data. So now what he is showing, that this he has plotted. See, line regression a plus bx. He has plotted on that your software that was there. Okay. So what are the commands and all? You can see it here. Is it visible? Yes. So you
Mm-hmm.
can see it here. The commands and all on the software. So now residual plots. What are the residual plot? A residual plot is a scatter plot that displays the residual on the vertical axis and the exploratory variable on the x-axis. We'll now
Mm.
there is a scatter plot. There is a Now we have seen scatter plot. Yes or no? Scatter plot.
Mm-hmm.
What was it? Scatter plot was
Scatter
generally
plot.
the explanatory variable was on the x-axis, just revising for the purpose, and response variable was on the y-axis, and we used to plot the scatter things. Okay, but now, but now, but now we have to plot. We have to plot the residuals, the squared residuals, the squared residuals on the x and y axis, So what will be our graph for residual plot? It is very important. Residual plot, residual plot. So the thing is that on the y axis, sorry, oh no, that what is happening here, man. Okay, for residual plot, he's telling us that a residual plot is a scatter plot in which on the x-axis there is explanatory variable, correct? And on the y-axis, there are residuals that we are going to calculate, or the software is going to calculate. Likewise, 0, 1, 2, residuals, likewise that. Did you got that, Zaid? What is a residual plot? And then we'll
Yeah.
plot all the residue points depending on the explanatory variable, and then we'll draw all. Did you got that, Zaid?
Yeah.
Yeah. So that's the residual plot. You can mark it in your book also. So that's the main residual plot that C here. He has done this residual plot. See how much tedious it will be for plotting one by one, because there are so many points and the calculations on all. So this is the residual plot. Do you get that? What are residues? I've
Yeah.
explained you further. What are residues?
Yes.
Yeah. So that's the thing. Residues I've explained you. I'll just drink water and get back. You also. Okay. Just a minute.
Mm-hmm. Mm.
Thanks for waiting, Zaid. I have refreshed.
Yeah.
Drinking
It's
water.
cool. Yeah. Mm-hmm. It's
Okay.
fine.
So I'll write the definition here for the residual plot. So it will be plotting the residues, plotting the residues dues as a scatter plot by keeping exploratory variable, explanatory variable on x, and the residual frequency and the residual frequency on the y, on the y. That was the definition
Bye.
of our residual plot. So we move on to how he is comparing. See, the least square regression line clearly doesn't fit the association very well. See, this was the least square regression line. Average income, here in frequency rate, and here residuals. This frequency rate, it is here in this, how frequent the data is occurring. And on the right, what I'll do, I'll take this whole explanation on our thing. Residual plot helps us assess whether or not a linear model is appropriate. The scatter plot shows the relationship between the average income, okay, and fertility rate. Okay, so we'll take this one on our board. So what he's telling, you can see here in this, here is the fertility rate. Okay, now what we have done, converted all these dot plots, so you can see the regression line is this. Yes or no, Zay? So there was many
Mm-hmm.
residuals here, this, and you can know, see how tough it will be to calculate the residues of all these points. So there is a specific command in the software that you have to do like that, and these is the residual. See, these all are the residual of all the residue plots. So this is the residual plot in general. These are the residuals on the y-axis, and the exploratory variable remains on the x-axis. So this is a residual plot. So what he needs to explain is that the d-square regression line clearly doesn't fit this association. So this line, that's the regression line, is not fitting. Is it fitting the association very well? You can see it here. Yes or no? See, it is a
Mm-hmm.
horizontal line that's coming. Yes or no, Zay?
Yes.
Yeah, so for most countries with average incomes under 5,000, the actual fertility rates are greater than predicted. So what he's telling that the for most countries with average income under 5,000 year, that's year under 5,000, the actual fertility rate are greater than predicted. So the actual fertility rate for these people will be more greater, as this line will predict more greater rates than we had predicted, than it was we will predict by this. Okay, so for countries with average income between 5,000 to $60,000, so between 5,000 to $60,000, so the actual fertility rate tends to be smaller. So it tends to be smaller. It's near down. Okay, but it in this it is going upside. So that's the thing is trying to explain here. See, in this also miles driven and miles driven. These are all the residuals, and this is the price. So now he's explaining. Look at the scatter plot. The line seems to be a good fit. This was the first line when we were plotting the scatter plot and the regression line, and this one is our residual plot. See, there is more difference between residual plot, and this residual plot is exactly as zero. Okay, okay. This line comes for the zero. Now we'll predict the things by this residual plot. So looking at the scatter plot, the line seems to be a good fit for this relationship. You can see the line is appropriate by the lack of leftover curve pattern in the residual plot. In fact, the residual look randomly scattered around the residual equals to zero. So now we'll do one exercise so it will be more clear. Come on, read this example. Zay. Come on. I'll drink water. Bismillah.
Eh, it looks more like a
Okay.
parameter. I
Uh,
don't think it's a linear model.
yes, it is a linear model appropriate to describe the relationship between the weight in carats and price in dollars of round, clear, internally flawless diamonds with excellent cuts. We calculated a least square regression line using x equals to weight and y equals to price, correct? So y there will be residuals in our residual plot, and may the corresponding residual plot shown. Use the residual plot to determine if the linear model is appropriate. So the linear model
I don't think.
relating the price to carat weight is not appropriate because there is a U-shaped pattern left over in the residual plot. Yes or no? There
Yeah.
must be a straight pattern.
Yes.
It is a U-shaped pattern or not here in this residual plot?
Yeah, it's very U-shaped.
Yeah, it's a U shape, so it is not appropriate. The residual plot is not appropriate. Okay, did you got this? It
Mm-hmm.
must be a
Yeah.
straight pattern. Likewise, see here, these points they are scattered, much scattered. These are also not a perfect linear. Okay, okay. So we'll move on to the next question. See this. Think about it. Why do we look for patterns in residual plots? The word residual means the Latin word residum, meaning leftover. When we calculate a residual, we are calculating what is left over after subtracting the predicted value from the actual value. Correct. So residual is
Mm-hmm.
actually actual value minus the predicted value. We have seen how to calculate the residues. So form of residual plot is form of association when minus form of model. That's the thing.
Mm-hmm.
So making residual plots here in your what you'll say software is given there. Okay. Alhamdulillah. So now what we have to do in exercise 3 and 7, we asked you to make a describe a scatter plot for hiker data shown in a table. So calculate the equation of the least regression line. Okay, so you have to plot these residual on your pen and paper. Okay, then you have to calculate the equation of the least regression line. Make a residual plot for the linear model in question 1. What does the residual plot indicate about the appropriateness of your explain your answer? So what I'll do, you'll do this for homework. We'll discuss this sum inshallah tomorrow. The whole sum we'll discuss it tomorrow. First you will have to do it. Okay, this will be your homework.
I'm
So next,
mhm.
see the how well the line fit the data, the role of S and R square in regression. So what's S? We know what is S. What
Yeah,
is S, Zaid? Do you remember?
S is the standard deviation.
Yes, standard deviation. And what is R square?
R squared is part the regression line thing, the
Okay.
residual. R is residual. I know R squared is just
Square of the
percentage of it.
residuals. You get square of the residuals.
What?
What is R square? I'm asking.
Um, R squared is
We have seen R square.
uh yeah,
See,
R squared is the coefficient of determination.
coefficient of correlation. Correct. Coefficient of determination. Yes. So once you determine that at least what you will say that a square regression line is appropriate, it makes sense to ask a follow-up question. How well does the line work? That is, if we use the least square regression line to make predictions, how good will these predictions be? So what we were generally doing, we were plotting the least square regression line because we wanted our, what you'll say, predictions to be more accurate and more fine with our readings. So this is the thing
Yeah.
that we have to do to assess how well the line fits all the data. We need to consider residuals for each of the trucks. See, he has calculated all the residuals. And now what he'll do, he'll plot it on the thing. Okay, so this is how he has done.
Mm-hmm.
Okay, now we'll move on to the next. Now we have to now see, there comes a big topic in the sense, we have done all these things in our previous classes. That's what we are doing. Now we are with a thing that we are looking into residuals. We are looking into residuals. Okay, so now we learn the characteristics. Now we will learn all the characteristics of it, all the characteristics of it. Why we are looking into its characteristics? Because we are studying or predicting, or you can say predicting the values using the regression, using the not the residual regression line, but the residual plot line, residual regression plot line, residual regression plot line. So this is very important to study its characteristics. So first characteristic that given in the textbook is the standard deviation for for the residuals, for residuals. Okay, that the standard deviation of the residual S measure the size of a typical residual, that is S measures the typical distance from the actual Y values and the predicted Y values. So it's very important that what does it do? What does standard deviation generally do? That is like that. For example, here on this, it was the actual Y, and for suppose this is the predicted Y. So it compares the
Mm-hmm.
variability. It is the measure of variability in the Actual predicted value, actual value, and the predicted value, and the predicted value. Did you got that? What is S doing
Yeah,
in here?
got
Yes.
that.
Yes, variability. How much variability or difference is there in the model when it is plotted actual with the actual plots and with the predicted plots? Thing.
Mm-hmm.
Okay. So see here, you can write this formula in your book. Here we are doing n minus 2 because we are bringing things to more to down things. That's the reason we are subtracting n minus 2. In the previous formula, we did n minus 1. So what we have to do in S, what's the formula for S, standard deviation? It will be
Wow. Yeah, like square root of actual minus predicted.
of square residuals upon what he has done, n minus 2, n,
Mhm.
n minus 2. So what it is? Sum of square residuals. Sum means summation. Y means Y predicted. Y predicted is minusing, or so okay, first he's minusing the actual one. So Y
Actual.
actual minus the Y predicted. It's sum of square residuals, no? So squaring it and dividing by n minus 2. You got that the formula there? They can ask you in
Yeah.
multiple choice questions. Right. See what he has done for this data. Here he has given the data here. He has done that thing for this data. Okay. Did you got that? You can also perform this.
Mm-hmm.
Come on, do this. You'll see what your answer comes. Come on, I'm waiting here. Do this.
Yeah.
So if calculate is it, I think you
Yep.
are yes.
Still calculating.
Okay, okay, calculate. Yes, good.
Square root of negative 1.12.
Square root of
Okay.
negative. How can it be negative? You are squaring the values, na, say. So it cannot be negative.
Yep.
See, we are squaring sum of square. I've told you. First, you have to square it, and then you take the sum of each value. So it is around 461124136 divided by 14, and then taking the square root. So the value is around is typically the actual price of a Ford is typically about rupees the dollar 5740 away from the predicted price by least square regression. So for suppose if I am predicting For suppose, what does this mean? That our S is
Yeah,
dollar
but
5740
wait, I
away. So what does this mean?
yeah,
Our Y,
yeah, but just give me a minute.
am I audible?
I'm almost done. Yeah,
Yeah, okay.
I
So
just
our
have to square
output,
everything.
he has predicted 16,000. So our actual price will be 16,000 minus 5740. Okay,
Mm-hmm.
so it will have a difference of around $6,000. So it's a great difference. Okay, see here. Does the formula S look slightly familiar? Should in chapter 1 will define the standard deviation of a set of quantities data. See, the formula was n minus 1. Okay, so we interpreted the results value as typical distance of the data points from the mean. In first chapter, we were seeing how the values were variable from the mean, from the center value. So it was the standard deviation. Now here in this thing, we are seeing the variability in y predicted and the y predicted. This is the thing. The S is used here in different forms. So now the coefficient of determination, that's r squared. So what's the coefficient of determination? See,
R squared.
so the coefficient of determination measures the percent reduction in the sum of squared residues when using least square regression line to make the predictions, rather than the mean value of y. In other words, r square measures the percent of variability in the response variable that is accounted for the least square regression line. So we are generally seeing the variability. Now, what does r square is doing? S was seeing the difference between the variability, also we can say the difference between the y predicted and the y actual. But what is r square doing? R square is doing seeing the variability in the response variable, but the thing is, but when done by least square regression, when done by it, these are the characteristics of least square regression, these S and R square. The formula only fits when least square regression we have used. So that's the thing accounted by least square regression. So this is the thing. This is more theoretical rather than being practical. These things are more theoretical and they are more reasoning, by the way. So see, suppose we have predicted. So come on, read this.
Hello?
Yes.
What did you say?
Yeah, read this. The problem on the window. See how is explaining. Suppose we wanted to predict the price of a particular used for F-150, but we didn't know how many miles it had been driven. Our best guess would be average cost of a used Ford. Yes or no? It would be average cost of a Ford if we don't know how much kilometer is driven. Of course, this prediction is unlikely to be very good, as this price vary quite a bit from the mean. Okay, so if we knew how many miles the truck had been driven, we would use the least square regression line to make a better prediction. How much better our prediction that use the least square regression line with x equals to mile driven, rather than predicting that use the only the average price with r square. That's the thing. See here, he has explained how to see this. Then the r square also measures between 0 to 1. R square is generally the coefficient of determination. Of determination. Coefficient of determination, that's r square. It generally ranges from 0 to 1. The bigger the value, the exact will be our data. See, I is calculating the r square. He's taking all the sum of the square residuals about 1374000. If we use the mean price as our predicted for all 16 drugs, the sum of the square residuals from the least square regression is about 461. To find the r square, calculate the percent reduction in the sum of the square residual. So what we have done, we have subtracted this value, the sum of the square reduction, if we use the mean price as a production of 16 drugs. So this is our predicted value and this is our actual value. We'll subtract the actual value from the predicted value divided by the predicted value. So it came out to be 0.66. The sum of the squared reduction has been reduced by 66%. So see how much reduction it is. By doing the sum of the squared residuals, we have reduced our data prediction to about 66%. So what does it matter? The reduction in our predicted value. Yes or no, Zaid?
Yeah.
Yeah, so Alhamdulillah, I think we have completed the residual plots and it's all the things. So now see, we'll do one question. I think interpreting computer, we'll see how much is left. Acha, regression to the mean. Okay, there is regression to the mean. Okay, then correlation and regression wisdom. Yes, it's quite important. Correct. So there is a definition. Okay, then it is higher leverage, outlier, and influential point. Okay, then we come to this. It's interesting topic. Right? So I think we were on this topic. Come on, read the question. This question, read it, and tell me the answers.
Mm-hmm. R squared is 69. It's moderately, you know,
Okay,
wrong. Yeah, moderately positive.
interpret
And the
your
S is the how much increase it is.
yes.
Yeah,
So the value of S is around 4.03. So what does S say? How
yeah.
much difference is there in the predicted
It's the
value and the actual value? So the actual number of the starburst candies grabbed is typically about 4.03 meter away from the number predicted. Means,
hmm?
for example, in this example, what we have seen that he's giving, I think, example of candies, correct? What he has taken, Mr. Tyson class along with the hands. Yes, the candies that the hand can hold, the candies for suppose hand span can hold, hand span holds. This what we'll do. This the actual number of candies is typically about. Okay, so for suppose I have taken candies capped as 10, so the actual will be 10 plus 4. So this is the predicted and this is the actual. That's 14. You got that, Zaid? What is S showing? How he has interpreted? Did you got that?
I definitely got that.
Yes. So come on, interpret the value, the value of B. Interpret the value of R square. Come on, fast. Interpret it.
All right, I'll do that.
Okay. So the R square value was, I think, the about 69.77% of the variability in the number of starburst candies grabbed is accounted by the least square regression. So least square regression
That's what
has
I said. I said it's the, the blind thing, the percentage. It is strong or moderate.
correct, correct, correct. Yes. Okay.
Okay.
So interpreting computer regression. So this is your software thing and all. So this question will be for homework. Is it okay, Jay? This one, the two questions
That's
are
totally fine.
today for homework. So we'll end the class here. This is an interesting question. You can try that.
So
Uh,
soon?
yes.
Let's do a little bit more time.
More time I shall take today.
Yeah, just it's 7 minutes more.
Okay. Okay. I'll take it. I'll take it. So what we'll do, we'll discuss the example here. Come on, sir. We'll discuss this example. Come on, read it. Read this example.
Mm-hmm. Okay.
Okay, so he has given generally the least square regression line added, a residual plot, and some computer output. So looking at this, is a line an appropriate model to use for these data? Explain how do you how you'll explain?
Yes, because there is a trend of positive
Correct, correct. Yes.
going up. Yeah.
So positive correlation or positive association, you can say. Yes or no?
Yeah.
Yes, so see, he has given that because the scatter plot shows a linear association and the residual plot has no obvious left over curved pattern, a line is an appropriate model to use for this data because it is a linear association. Here you can see in a straight way, and it's also a positive correlation, so it will be a best fit. So find the correlation. So how you'll find the correlation? So how he has done see R is
We
around
just square root the r squared.
0 point, yes, R squared. Yeah, correct. There it was. I'll take this on our boards. So see here is the R squared value. This is here. So R square is around 0.486. So what will take the square root of R, it will be root of 0.486. So square and the square root gets cancelled. So R is around, what is the square of 0.486? As done it here, it was 0.697. 0.697. That's correct. Did you got that? Yes, you
Mm-hmm.
told me
Yeah.
that. Correct. What is the correlation? What is the equation of the least square regression line that models the relationship between foot length and height? Define any variables that you see. Come on. It's very interesting. Here he has given the things in this data. See here. Can you tell me the equation? Say. It's generally I'll write.
Uh,
What we have to generally predict
it
is like yeah.
is
Y
um it is 103.41.
y cap
It's
b
y hat. Yeah,
I,
y hat equals to
yes
103.41
yes
plus 2.7469
y. Yeah, sorry, x
times
correct?
times the foot length.
X variable, yes, for that, yes. That's correct. Correct, Zaid. Yeah, you are correct, man. What's the next question?
Mm-hmm.
By about how much do the actual heights typically vary from the values predicted by the least square regression? So where you'll get it
From
is
the S value 7.95.
correct. 7.95 the S, correct. So it will be so the actual heights typically vary about 7.95 centimeter from the values predicted by regression line. Regression line that's x equals to foot length. He is explained
Mm-hmm.
that vary about the regression line. This line by x varies to foot length. Here he has the two graphs here. Yes, this data varies by this by 7. That's the same. Yes, that we have completed. Come on, read this example also. We'll solve this because that's a new topic, regression to the mean. This one. He's explaining how to calculate the regression to the mean, and there are different formulas. I think that it will be better if we start yes tomorrow. Okay,
Fine,
so
okay.
read this example, come on, and do this now. Okay. So I think it's easy. I'll take it on as our board.
The equation is
Okay.
y hat equals to 33.34 plus is it plus or
Like,
plus 13.28 times the duration.
okay.
Mm-hmm.
Next, what is the interpret the slope of the least square regression line? What will be the slope?
Now the slope is
Positive.
uh
So it will be a positive correlation. Slope generally tell
yeah
about how the inclination of line is. So it is positive. So it will be positive. Yes or no, Zaid? It is positive.
yeah
Yeah. Yeah. So it will be a positive correlation with a positive
mm-hmm.
association of the things there will be. Okay. So next is identify and interpret the standard deviation of the residuals. What will be the standard deviation of the residuals? Standard
The
deviation
slope.
is S of the residual will be the root of 0.85. Yes or no?
Mm-hmm.
Yes. So what percent of the variability in the interval is accounted for by the least square regression line with x equals to duration? So what's the answer?
0.85.
Correct. That's good. So now we'll start a new notch. It is a subtopic of our thing. Just it's all about regression to the mean. We need to calculate the regression to the mean. It's represented by b, y on x and x on y. Depending on the thing, the things changes. Whether we are taking y on x or x on y.
Mm-hmm.
So there's an example. There's a formula. I think there's an example. So shall I stop here? Is it okay?
Yeah,
Yeah.
yeah,
So
that's
have
fine.
seen revised. Okay. So you be aware of the test that will be on Saturday, inshallah. I'll forward
Yeah,
you the test paper at what time you'll check. Is it clear? So what I'll
yeah.
do, I'll stop the class now. Okay. So you study for the
Mm-hmm.
test. Okay. On chapter
Yeah,
one. Assalamu alaikum. Good.
yeah. Walaikum salam.